Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
This episode is proudly sponsored by Metageek. For more than a decade, network professionals have used Metageek Wi-Fi tools to deploy, maintain, and troubleshoot wireless networks. Visit metageek.com/CTS and use the code CTS10 at checkout for 10% off your purchase of Metageek brand hardware and software. Hey everybody, thank you for joining us on a brand new episode of the Clear to Send podcast. You are joined by myself, Roel, and our host, Francois. How are you doing, Francois?
I'm good. Hi, how are you?
Dude, I'm doing great. This is a first episode for us where you're actually across the Atlantic and in another country.
Yeah, I'm in France right now, so...
Yeah, must be nice. Good. So it's early morning for you and a late evening for me. So somehow we managed to squeeze in this this recording for everybody. So that's going to be interesting. Usually it's switched around. Usually you're later in the day and I'm really early in the morning.
Yeah, well, it works out this way this time. So
yeah, it's good because usually we're 3 hours. You're 3 hours ahead of me. Now it's 9 hours. It's quite a difference. But I'm glad you're able to join me on this recording. And this one of the reasons why you weren't able to join us on the last episode was just, scheduling. It gets complicated. But in this episode, we're actually going to talk about capturing wireless frames with your computer. And that's going to be for both your PC and your Mac. And we'll probably touch upon Linux, even though we're not heavy Linux users. But hopefully we can find some tools for everybody to use. What is your experience, Francois, with capturing frames? Like, why do you do this?
I think my experience goes back to when I started to study Wi-Fi. You want to start capturing frame and see what it looks like and get a sense of how the protocol works. In the field, I would just use it to mainly to troubleshoot or just to get the sense of what the environment looks like. I like to do that sometimes when, even though there's no issue, I like to just take a packet capture and try to analyze it to see if they could have potential issues. Wi-Fi is so resilient that sometimes people don't, the users don't even see potential problems. And we could just see them through packet captures. So that could be useful this way. But like we said, networking packet never lies. In our case, would be frames never lies, right?
Yeah.
But yeah. So
yeah, and usually the terms are interchangeable. People call them packet captures, frame captures. I would say the most proper term is a frame capture because in wireless we're dealing with frames, but people use them. The same term. And usually when you get to doing a frame capture, it's because you've pretty much exhausted all your other troubleshooting steps, such as troubleshooting your infrastructure, troubleshooting networking, any other protocols that might be involved. And then maybe as a last resort, you're going to pull out your frame capture tools and see what's going on in the air. What exactly is happening? Like, is my device or device you're troubleshooting connecting to the AP, or is the AP getting that frame down back to the client, that kind of thing. And so we're going to go over our some of our past experiences doing wireless frame captures. What kind of computers did we use doing that? What applications and tools are available for us to perform this kind of analysis? And for me, this all got started. I really started doing a lot of this when I saw Jerome Henry from Cisco doing his presentations on capturing frames and what kind of unique ways he was coming up with this information. Right? He would capture frames and then display them in graphs somehow. And I was like, well, how did he do that? And so maybe I can add also a link in the show notes showing the presentation he did for Cisco Live, how he was able to take, say, a frame capture and then put that into an Excel sheet and graph things such as data rates. He was able to say, okay, here's a device. Here's how it selected the data rate, how it dynamically rate shifted, things like that. Like that really gets you into looking at the protocol, how Wi-Fi works, and where you can spot some of the issues, especially when it comes to device drivers. And that's a very good example because every device driver is going to be different. So let's see. Where should we start, Francois?
Maybe we can talk about the different tools, and then while you were speaking, I was also thinking about the fact that sometimes you using some tools, you might even be doing some packet captures without knowing it in the backgrounds. Some tools like Wi-Fi Analyzer, or there's another tool I like to use when I troubleshoot called Debuki on the Mac, and those tools just perform packet captures in the background, and they just extract information from the packet and show it to you in the GUI. But yeah, maybe we can talk about the different tools, and then we can give the audience some examples.
Yeah. So my primary tool for capturing frames is actually my MacBook Pro, because the Wi-Fi device driver can go into what's called promiscuous mode, which is what we need to capture frames from the MacBook Pro and any other laptop that you're going to use or computer that has a wireless card. You want it to go into promiscuous mode. And with MacBook and OS X, there is an application. It's already built in. It's called Wireless Diagnostics. And when you open up that application, you click on Window over in the menu, and there is an option called Sniffer. And when you open Sniffer, you can select the channel that you want to sniff frames at and what channel width. And so mine can go up to 80 megahertz channel width. So I can do 20, 40, or 80. And then it'll start the capture. When you stop it, it's going to place it in my var/temp folder. And that's where that file is. That's the easiest way to get started. Now, when you do these frame captures, you're not going to be able to surf the web or anything using your wireless card, because it is going into promiscuous mode and is really just trying to capture these frames for you. And so once you stop that, then you could start using it again for normal data traffic. And once you have that file, you can open it in an application such as like Wireshark. Wireshark is the most common tool or application that I use to analyze these frame captures. Would you agree, Francois, or do you use another application yourself?
Yeah, I use Wireshark as well. If I want to get all the packets and the details, all the frames. I also use a couple of other tools if I want to get more analysis from it, like a quicker analysis from it. Usually when I'm on my Mac, I use just like you, I use the Mac to capture the frames, and then I use this tool called Mojo Packets. It's a website you can upload your PCAP file to, and then it will analyze the frames for you and tell you have this amount of association, this amount of deauthentication, this amount of retry rates. You are using these data rates, you have that many clients, and so on. So it gives you like a quicker analysis.
Yeah, and that's a free application to use. All you have to do is sign up with your email address, and you're able to upload PCAPs.
Yes, exactly. On the Windows side, you can use MetaGeek IPA. It's an application that does the same thing. So you upload or you capture directly from the application, and then the application will analyze the capture for you and tell you have this amount of, the management frame versus this amount of control frame, data frame, and you can get a sense of how the frames are, how the data rate or how the different SSID are affecting your throughput and everything, the airtime.
Yeah, and what I like about Mojo Packets and MetaGeek IPA is that they are visual tools. So they're able to put things into pie graphs, you can easily distinguish how many packets are, say, deauthentication frames. Sorry, not packets, but deauthentication frames. Or you can see how many retry frames are actually occurring on your network, because then that could be a sign of another problem. And these two tools will help you visualize that and help you basically come to the conclusion of, okay, this is the next step that I need to perform in my troubleshooting because I can see all these retries. So let me try to figure out why there's a bunch of retries. And now with the MetaGeek IPA application, you can capture frames, as Francois has said, directly with MetaGeek IPA, but you will need a capture card, which is called Air PCAP NX, and you can get that in dual band. And from there, the application, you just select what channel you want to capture with, or what channel you want to capture at, and what channel width. And then it just does that within the application. But if you don't have the capture card, you could also upload PCAP files into the application, and then that'll help you visualize it as well. So that's a very cool application. I've used it before. It's better than actually going through all the frames, right? Francois, like, it's really hard to look at that data and say you've captured 5 minutes and you've captured thousands and thousands of frames. And when you look at that in Wireshark, it's more of a, okay, where do I begin kind of question, because it's not easy to really see what the issue is unless you actually know what you're looking for.
Exactly. And what I like about IPA is that it will give you the airtime. So, right off the bat, it's going to tell you, okay, you're using 50% of the airtime. And then out of this 50%, it's going to tell you maybe 40% of that is management frames. So maybe you're like, okay, maybe I can optimize maybe I have too many SSIDs, and you can see all of the different APs and such. So you can also see how the neighbors are affecting the airtime. You might have neighbors with a minimum data rate enable and affecting the airtime. So it's a really good tool to visualize this. And because it's very visual, you can also use it for reporting if you're doing reporting for your customers.
Yeah, that data would make much more sense than saying, here's the list of frames that's causing issues on your wireless network. And they're not really going to know what a deauthentication frame is, and you basically start giving a lesson in the meeting.
Yeah.
But that's a good way to start. I mean, another application that you could use, since we're talking about Windows right now, and I do want to touch upon Mac again, but since we're talking about Windows, another application that I have used that's very good at capturing wireless frames is OmniPeak, and that's from Savius. They do a great job within their application of really showing you where some of these issues are, because they analyze a lot of that data for you in what's called an expert mode. So they do also use adapters, and what's neat with OmniPeak is you can aggregate multiple adapters. So if you've got, let's say, I don't know, you want to capture multiple streams as an example, right? You can put 3 cards, put them all in the same channel, and start capturing as an aggregated card. You can put them on separate channels. Maybe you want to capture roaming, and so you could aggregate that in different channels and capture the roaming process. And then when you bring that into the application, you stop the capture, it's already going to identify some problems that have occurred, retry rates. It's going to show you who's talking the most, who's taking up most of the airtime. A lot of different graphs also to look at, right? And I think that's very useful as well. That gives you a little bit more deeper analysis. It's not an easy application to learn. I think it does take some time, because it took me a while to understand like filters, for example, like when I wanted to filter down the actual data. So when I capture, I actually do not filter at the capture level. I will capture everything I can on the channel I'm trying to capture from. And then once I have all of that data, then I try to filter out what I don't need and just try to find what I do need. So things like your source, transmitter, destination, that kind of thing.
So you use display filters versus capture filters?
Yes, that's correct. I prefer to capture it all just in case I miss something. and I don't want to have to go back again and capture, or if you're having somebody else capture for you, you don't want them to either make a mistake on that capture filter. So you just tell them, just here's the AirTool application, and I guess we'll dive into that soon, but I want to capture on this channel. Just give me everything and then I'll find what I need.
So let's say you arrive on site and then the customer is telling you, okay, I have a problem with these, VoIP phones. How do you start your process? Like, how do you define which channel to capture on and everything?
Yeah. So the way I'd approach that is figure out where on the floor plan they're having issues. Identify the APs that are in that area. Start with one area, and if you have multiple adapters and using OmniPeak, you can capture on, let's say the first AP that it's associated to is AP1 on channel 1, and then the second AP is maybe 5 gigahertz radio, and it's on channel 36. I'll have one radio on channel 1, one radio on channel 36, and try to capture that roaming that you'd expect it to go from, AP1 to AP2, switch channels, and then you'd be able to see that roaming process, how long it took it to roam, especially if you're using security. And you want to see if there's, some sort of association problem. Maybe the security is taking too long for it to basically roam to the second AP. And then that means you could have problems with your voice traffic getting to the phone or leaving the phone, or maybe there's a coverage hole. Maybe there isn't enough. Maybe it's sticking to the first AP. It just depends. But usually the frame capture is the last part of the troubleshooting process. I don't use that first right off the bat. I use whatever tools are available, like looking at signal strength as an example and seeing, okay, well, you're in this area. Your RSSI is negative 79. That sounds like it's going to be a problem on your voice over IP phone. But when it gets down to that frame capture level, there's something seriously going on, right? Because you're actually looking at the protocol, seeing what's transferring over the air, how much time is it asking to, it wants to send traffic. How much time is it going to take to send that traffic? And it's one of those things where if you're going to do a frame capture, you pretty much need to know what you're going to get into, what you're looking for, right? Because you've exhausted all your other resources. You've looked at your wireless network system and determined, okay, there's nothing wrong here. There's no heavy channel utilization on any of my APs. The coverage is good. Capacity is good.
Yeah. You're usually filtering by the MAC address at that time. Like you troubleshooting a specific client or a specific AP, and you're just trying to see the specific frames for a MAC address.
Yeah, I was trying to grab some sort of scenario from something I've already done, but honestly, I haven't had to capture voice over IP. I have had to capture. One example that I've done is there was a conference room where people typically, use their laptops to display something on the screen, and they were what they were doing was showing something on the screen, but they were also doing a Skype call through somebody's laptop. So he was doing the Skype call on his laptop, which was displayed on the monitor. And every time they do the Skype call, they would just drop off of Wi-Fi. The call would just end and they'd have to restart the whole thing. And so I got called in to check this out. I noticed they were in a pretty much isolated area of a building. So there was only one AP. Coverage was good because the AP was in the conference room. There was no interference. There was nothing wrong on the network side. Everything was looking good. So I decided to look at do a protocol analysis to capture the frames. And I noticed there was a device on the same channel that had given out duration frames that were like incredibly long. Like it was taking up so much airtime that no other device was going to be able to hop on to this to the medium and send their traffic. It was every time it was sending frames with long durations. And so when I saw that, I tracked it down to an Apple TV. And I would shut down the Apple TV and Wi-Fi was working fine. Like there was no issues. So then I told the user, I said, hey, you should look into this Apple TV, either update it if it hasn't been updated or just replace it. So they opted to just replace it for whatever reason. And they said ever since they replaced it, everything's been good. And so that was one example that I used frame captures to actually see what the issue is. And that's something I probably wouldn't have seen in the systems that were available.
Yeah.
And you probably could have seen that with IPA if this one MAC address was taking up all the airtime.
Yeah.
And sometimes it's just drivers that just go crazy sometimes. Like they just need to be fixed. Either it's a bug or it's a bad wireless card. No clue, but sometimes the frame analysis gets you to that solution. This episode is proudly sponsored by IPA, the visual packet analysis software from Metageek. As a Wi-Fi professional, you probably understand the benefit of packet analysis for troubleshooting wireless issues. And if you have any experience with most common packet analysis solutions out there, you also understand that sifting through hundreds of lines of data to find the cause of a network problem is a little like looking for a needle in a haystack. IPA takes a visual approach to wireless frame analysis. So instead of dumping raw packets for you to evaluate, IPA presents your data in multi-layered pie charts that make it easy to understand which networks, devices, and packets are using your available wireless airtime. With fast and easy filtering options, color-coded labels to show data throughput versus management overhead, and expert tips based on observed conditions, IPA makes 802.11 frame analysis easier than ever. Visit metageek.com/CTS and use the code CTS10 for 10% off your purchase of IPA.
I think in this case, as I believe OmniPeak will tell you, it's like because you can change the duration ID to do like an attack, because pretty much everyone will just assume the medium is busy and not talk at all.
Right.
So it's crazy. Like on the spectrum, you wouldn't see anything, but nothing is working.
Yeah. Yeah. There's nothing really talking because the device that wanted to talk was already done. It was already done transmitting its data. It was just, and I've heard about this. I've heard stories of people saying they've seen drivers where the developer just wanted to have their device preference on, give it preference to communicate on the wireless network faster. So what they would do is set a long duration frame, because then that gives you all the time you need to transmit the data.
It's kind of like when the developers set everything to voice, like the QoS to voice. It gives a purpose, yeah.
Yeah, I was looking at what was I looking at? I was using a MikroTik to do frame. I was looking at not frames, but I was just looking at a packet capture, and I was doing a speed test to see like which IP it was hitting, and I would see that it would see that the destination server for the speed test, and it classified it as SIP. So
okay,
it was picking it as voice, and I was like, oh, okay, so that's how you get your fast speed test. It wasn't wireless, but it was just interesting to see. Actually, I was doing the speed test over wireless, but I had hopped onto the infrastructure side to capture that packet, and that was interesting to see that it classified that traffic as SIP traffic, so it had higher preference on the network.
Yeah, I see that often too.
So, I wanted to go back to the Mac because I don't know. I like using the Mac. I think there's more flexibility, more freedom to do things on a Mac. And my favorite tool of all time to do any frame captures is from Adrian Granados, and it's AirTool. AirTool gives probably the ease of use of capturing frames because you don't have to go through wireless diagnostics where you don't have much, I guess, options for your frame capture, whereas AirTool, you're able to pick a different channel, select the channel width. You can also it automatically opens in Wireshark. There's a couple other settings. I know I'm forgetting some. I should know these.
You can select the channel width, the channel. You can select the size of the capture file.
That's right.
Yeah. You can also upload directly your capture to online services such as CloudShark and Mojo Packets.
Oh, okay. You can do Mojo Packets now. That's a new one. You could actually do multiple channel capture with AirTool. I haven't tried that one yet.
It's going to scan though. It's going to scan through the channels, so you might miss.
Miss some frames.
You will miss some frames. Yeah.
So there's a dwell time. It's going to dwell on that channel for I don't even know how many milliseconds he put it at, but it's going to hop on each channel. And that's where having the separate capture cards is an advantage, because you're not having to hop on those individual channels. You set a capture card to a channel and it's always capturing. I think one of the coolest things with AirTool as well is just, you said earlier how much you want to capture. So you can actually drop all the rest of the payload if you just want the headers.
Yes.
And I think that would save a lot on your the file size of your capture, because if that's all you're really looking for, you want to see things like the radio tap header, and that's one thing we haven't spoken about. The radio tap header is really nice to have when you're capturing frames. And this is something that the driver would provide within the capture. Not all drivers would do this, but the radio tap header, and as I pull up one of my captures here, they add in a lot more data. So there's a lot of flags that tell you, what if the channel is present, what channel it's on, the antenna signal. What else does it? The receive signal that it received that frame at.
Yes, the noise, the channel, the data rate.
Yeah, data rate's a good one. And one thing to notice about the noise, though, is the noise floor is calculated based on the wireless card. And since the wireless card is not a spectrum analyzer, it's only calculating the noise based on the 802.11 frames it could demodulate.
This is going to be used for the SNR, which is directly related to the data rate. So that's important too.
It also can give you MCS information if the driver is giving that to you. That's really nice, because I'm looking at a frame and it's telling me MCS index 2. So that's cool. And actually I've used this looking at deauthentication frames. There was one site where users kept saying they kept getting dropped off of Wi-Fi and not reconnecting back. And so when I headed over there, I didn't see any interference, but it was a large office tower. So there's a lot of other networks around the area. And so right away I thought, okay, this could be maybe something malicious, maybe not malicious. So I started capturing on the frames where they were, channels where they were having issues, and I saw deauthentication frames. And so when I'm trying to find, when I saw these frames, I was like, okay, where are these coming from? It's not any of their APs or any rogues on their network. It's coming from a neighboring network or a neighbor. And so what I would do, trying to find that source, I would use the radio tap header information. So I would capture on that channel and I would look at the signal and I go, okay, it's negative 93 dBm is what I'm hearing this at. So then I would move to a different location, capture on the same channel, look for those deauthentication frames sourced from the BSS ID that it's coming from. And then it would show up as a stronger signal strength. So that's when I'm moving closer towards the source of the deauthentication. So that's how I used Wireshark and AirTool to figure out, okay, where's this person coming from and who's sending deauth frames at me. And so that's one way I used frame analysis to figure out an issue and try to resolve that.
So who was it?
It was their neighbor.
You have to finish now. Yeah. Okay.
It was their neighbor. And another way that I figured this out as well, because that process is longer, right? Trying to capture frames, look at the signal strength, and move on. What I would do is you capture the frame, you see the BSSID of the DAuth frame. Just look for that BSSID and find a beacon frame if there's one sourced from the same BSSID. And the beacon frame will display the SSID, and usually companies put their company name in the BSSID, so I was able to find the neighbor quickly. That's an easy way to do it.
Okay. The SSID wasn't "I love my Wi-Fi." No, not this.
It's I hate my neighbor. No, and we spoke to them, and they didn't believe us. So, and since I don't have access to their network, they didn't. I don't know where that went. I told the client, and they said they would handle it, and maybe they handle it. I don't know.
Like lawyers and everything?
No, I think they just went, person to person. Yeah. Try to do it civil first.
Yeah. All right.
Putting a lawyer on them, so that's a drastic approach as a first step.
I know. I was just kidding.
Although you're not supposed to do that in the United States, so they could end up like Marriott when they got fined.
Yeah. Yeah.
So what else can we talk about with frame captures? I mean, I like doing frame captures. It's a great way to educate yourself on the wireless technology. It's great for CWAP if you're doing the CWAP exam with CWNP. It's a great way to really understand what's going on.
If you're studying any CWNP exam, and you just open up what I love about packet capture is that when you open it up with Wireshark, for instance, it will use all of the standard vocab, right? So it will tell you like, I don't know, VHT, CCK, OFDM, whatever it is. And then if you just want to study or learn new stuff, you just open a packet capture and try to study everything, all the acronyms in there, and you'll find something new every time.
Yep. Yeah, for sure. And if you go through and just use Wireshark, right? If you want to get started in this, use Wireshark. If you're on a Mac, use Wireshark and AirTool, the two best applications you could use for this. And then on the Windows side, you'll probably have to get an adapter that you can put in promiscuous mode. I use Wireshark and the Air PCAP NX adapter to start. And then, once you understand using Wireshark, you can jump into the other applications as necessary. But go into every frame that you see and look at what parameters are there, what flags are used, what kind of frame are you looking at? Is it a beacon frame, a probe request frame? Like, this is how you understand how devices connect to Wi-Fi, just looking at these frames. So,
so how do you set up your Wireshark to display the good columns, the useful columns, and what filters do you use?
Yeah, so I use I like to set the time of when the frame was captured versus like I think it's like relative. I don't use the relative time, or I could be wrong. I'll have to look that up. And then I use a profile that Joel shared out from MetaGeek. They colorize the different frames. So I use, I'll try to find that and link to it in the show notes, but that really helps distinguish what frames you're looking at versus everything being a white background. You can see it'll color different frames depending on what they are. And so I have my source, column, destination, what channel. I got data rate on there. That's what I start out with so far. That's my basic.
I have the same. Channel, signal, protocol, transmit rate, length, MCS.
MCS is a good one. Yeah.
Yeah, that's what I have. And I also use a color from IPA. That's pretty cool.
Yeah. So I'll try to find a link out in the show notes for those, the profile that you could upload into Wireshark. That'll be very useful for you. I highly suggest using it. And then I use a lot of display filters. So I'll look for like a transmitter address. So if I'm troubleshooting a specific device, I'll grab that MAC address off that device and look for that MAC address within a frame capture or any other address, really. So transmitter address, receiver address, or destination address. I'll look at a lot of management frames. So I want to see things like beacons. What are the parameters of the Wi-Fi network you're looking at? What are the supported data rates? What security does it support on a network? Is it high throughput, very high throughput? There's just a lot of information. It just depends on what you're trying to troubleshoot, right?
Yeah. Management frames are very useful. Association requests for clients or probe requests. I also like to analyze the association process, right? Mm-hmm. When a client's just first connect to the Wi-Fi, what's going on, how long it's taking, which type of security are they using?
Yeah, and a common problem too is how long it takes to get on the Wi-Fi network, right? So you could use that exact process you talked about. Make sure it associates properly, joins, you get that association. And then after that, right, if that's all good, you can actually see how long it takes to get your IP address as well. And so you can see the time difference from when that request got sent out and when the IP address gets offered. And if you just look at the times and the timestamps and then look at the difference and go, okay, it took 15 seconds to get an IP address. That could be bad, right? Especially if you're roaming and you have to get an IP for whatever reason. I mean,
what would you need an IP like?
You'd be surprised at some people's setups. My environment's so complicated there's different entities, but different entities broadcasting the same SSID names it gets ugly very quickly, especially when they're neighbors.
And when they don't use the same, they probably don't use the same VLAN subnets and everything, right?
Yeah. The different entities use different VLAN numbers, different controllers. Oh, it's just, and then and you'll have buildings that are mixed. So there's like a floor that's associated with the entity I'm part of, but then there's 2 other floors that are part of the other entity, but everyone's still broadcasting the same SSID. That's a different problem. I could talk about that for a while. Yeah. But what we want to do, since we're at the tail end of this episode, is Clear to Send partnered with Senfio Networks, which is Francois. And he was able to customize a sheet that he has, which is the most common 802.11 filters that you could use in Wireshark. And so we're going to leave that up on the show notes. All you got to do is leave your email address. You'll get put into our email list. We don't spam you guys, but we just let you know, okay, here's a new episode, and we plan on releasing some news about wireless, but you'll get that as a download, a PDF download. Very useful because it's hard to remember any of these display filters. If you use them enough, you'll end up remembering them, but this is a good cheat sheet that you could leave, on your cube, on the wall. Leave it on your computer, handy for when you need to troubleshoot and bring up Wireshark. And I want to thank you, Francois, for creating this, because I know I've used this before, and because I can never remember, subtype 40. What is that?
Yeah. It's the same for me. I built it myself, but I always go back to it because I cannot remember everything. Yeah.
Yeah. All I really remember are is the type 0, and then the first like 4 subtypes.
Subtype number 8. That's the one I remember.
Beacons.
For the beacons, yeah.
Yeah, that's a common one. And so you'll. This is really great too. Study material for CWAP. I think that actually for any of the exams, this is great to know, because if you're going to go into the security portion of the CWNP, you're going to start looking into some of these frames as well, and you're going to want to see what that looks like, especially the reassociation. If you've got security enabled, you want to know what that reassociation looks like when it goes through the security process again.
Yeah.
So yeah, it's great. And one of the ones that I'm familiar with most recently is the filter for deauthentication. So what I'll do is try to create some screenshots of what these filters would look like when you're troubleshooting, and how I was using it to troubleshoot as well. Cool. Anything you want to add?
Sounds good. No, I think it was pretty good. Oh yeah, we didn't talk about Linux. You can do some packet captures with Linux. There's a tool called Airmon. Mm-hmm. And I think in the AirCrack tools, Airmon is included into it, so you can also capture with AirCrack.
Okay.
And you just need the proper driver and the proper card. It's not too hard in the 2.4 gigahertz band, but I think it's harder to find a driver and a card that you can put in promiscuous monitor mode in 5 gig.
Yeah, see, that's why I just use a Mac and use AirTool and have it open automatically, Wireshark.
Yeah.
I just want to troubleshoot the issue. I don't want to have to troubleshoot my computer when I can't get it to capture frames.
Yeah. But, not everyone has a Mac.
Yeah, that's true too. But we at least helped you guys outline some of the tools on the 3 major players, Mac, Windows, and Linux. Sorry, we're not too familiar with the Linux portion, but I have used the Windows side before, and Francois and I are very familiar with the Mac side. But we want to thank you guys for listening to this episode. Again, head over to the show notes if you want to download that cheat sheet, and say thanks to Francois for creating that for the Clear to Send podcast. And also, we want to remind you to take our survey. Let us know how we're doing. Provide any feedback. You can head over to cleartosend.net/survey. It's only going to take about 5 to 7 minutes of your time, but we would greatly appreciate it as we try to figure out what we should be planning for 2018, what kind of episodes we should be releasing. We just want to provide more education, more relevance to you. We want to know what you guys think about how we're doing, so that way we can improve the show. And we just try to do our best to get these episodes out, because we're also learning as well, right, Francois?
Yeah, we actually get some really good feedback already. Very, from people that have been doing journalism and stuff like this before. So it was pretty.
We got some tips on how to interview people, so that's great. I like those. I like that kind of feedback, and we find that people like hearing more about these kind of episodes as well. So I guess we'll have more in the hopper for these kind of episodes.
For sure.
Cool. Well, where can people find you, Francois?
Online, Twitter, @VergisFrancois, on my website, semfionetworks.com/blog. And that's on LinkedIn as well. I'm pretty active on LinkedIn.
Cool. And you guys can find me @Raul Dionisio on Twitter. You could also find the Clear to Send podcast @Clear to Send. And you can find everything about Clear to Send on the website, cleartosend.net. And we want to thank you guys for listening. We greatly appreciate you. We hope you found this episode useful, insightful, educational. And if you did, please do share it with your colleagues or with any of your friends, whoever you think could find this beneficial. And lastly, don't forget to subscribe to our episode over on iTunes. Just open up your podcast app, do a search for Clear to Send, and hit subscribe, and you'll automatically get those new episodes downloaded to your phone. So once again, we want to thank you guys for listening, and we'll see you on the next episode.
Thank you, guys. Bye-bye.